Welcome to this explainer. Today, we're taking on a genuinely massive challenge. We are going to compress 4.5 billion years of planetary history into one single cohesive timeline. Now, when you're dealing with billions of years, the numbers kind of just become meaningless to the human brain, right? It's just too vast to really comprehend. So to actually grasp how long it took for our planet to transform from this glowing ball of magma into the world we're sitting in today, we need a physical map. So let's dive right into this. How do you visualize 4.5 billion years? I actually want you to try something physical with me for a second. Go ahead and just stretch your arms out to your sides, literally as far as you can, from the very tip of your right middle finger sweeping all the way across your chest to the tip of your left middle finger. That entire span, that represents the complete 4.5 billion year history of Earth. Now, what's wild here with this wingspan metaphor is just how skewed this timeline actually feels to us. Take your entire right arm, for example. That whole thing is a hellscape of molten lava and meteor impacts. Your torso? That represents a couple of billion years where literally nothing exists but microscopic sea slime. It is not until you reach your left wrist that animals finally show up. Dinosaurs? They're somewhere in the middle of your left hand. In all of human history, I'm talking the pyramids, the Roman Empire, the Industrial Revolution, all of it fits on a microscopic sliver at the very, very tip of your left fingernail. When you put it like that, humans really haven't been around long at all. All right, let's start at that right fingertip 4.5 billion years ago. The sun forms, and gravity pulls this clump of rock and metal into a molten sphere that we now call Earth. All the heavy elements like iron and gold, they actually sank to the center to form an inner core. And this is absolutely crucial because that heavy core created the magnetic field that still shields us from deadly solar winds today. But man, it was a violent neighborhood back then. A Mars-sized planet named Theia slams into Earth, blasting this massive sphere of magma into orbit, which eventually cooled to become our moon. Finally, around the 4 billion year mark, asteroids deliver water, and the rocky crust cools, cracking and hardening kind of like a freshly baked loaf of sourdough bread, which allowed the very first oceans to actually form. And it's in those early oceans where we see the unstoppable recipe for life. 4 billion years ago, deep underwater, near boiling hydrothermal vents, something wild happens. These vents were just packed with energy, and they were pumping out 6 crucial elements: carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. When those elements mixed with nearby ingredients in that extreme underwater environment, it triggered this unstoppable series of chemical reactions. Basically, they created precursors to amino acids, lipids, and eventually self-replicating RNA. So the big takeaway here is that life wasn't just a sudden, magical cosmic spark. It was a complex, continuous chemical process that once it got going was literally impossible to stop. Moving down your arm to, say, about your right bicep, we hit 2.7 billion years ago. Enter LUCA, the last universal common ancestor. Now, LUCA was a single-celled organism, and it is quite literally the ancient great-grandparent of every single living thing on Earth today. I mean it, from the cactus sitting on your windowsill to a great white shark, all the way to you and me. LUCA's descendants just completely took over those primordial oceans. And those descendants, specifically cyanobacteria, they went and invented a groundbreaking biological technology, photosynthesis. Up until this point, which is roughly around your right shoulder on our wingspan map, the Earth was wrapped up in this warm, cozy blanket of methane gas. But these cyanobacteria started pumping out oxygen. Now that sounds great to us, but 2.4 billion years ago, oxygen was incredibly poisonous to the original anaerobic microbes. So this shift wiped out most early life on Earth during what we call the Great Oxidation Event. And to make matters worse, by destroying that methane, they completely removed the planet's greenhouse blanket, which plunged the Earth into a massive snowball ice age that lasted for hundreds of millions of years. But hey, Earth's climate wasn't the only threat out there. About 2 billion years ago, a massive asteroid crashes into what is now South Africa. This is the Vredefort impact. This rock was 20 kilometers wide. To put that into perspective, that is exactly double the size of the asteroid that eventually killed the dinosaurs. No joke, it hit with such mind-boggling force that it literally folded the Earth's crust back on itself. This impact buried massive South African gold fields, perfectly preserving them for us to find today. And it kicked up so much dust and carbon dioxide into the air that it actually likely helped thaw the Earth out of that freezing snowball phase. Meanwhile, underwater, life was recovering and, well, getting highly organized. Think about microbial housing for a second. Simple bacteria are kind of like a studio apartment. Everything from DNA to proteins to waste, it all just floats around in one open space. But as microbes mingled, bigger cells actually started swallowing smaller ones. And instead of digesting them, those swallowed cells became specialized powerhouses, like mitochondria. This created eukaryotic cells, which are much more like a luxury mansion. They have a nucleus, specialized rooms, all neatly wrapped up in their own membranes. Fun fact, you are a eukaryote. And this incredible leap toward complex, multicellular life, that took up most of your upper left arm on our timeline. Okay, let's trace this down to the left bicep and to the left wrist and watch how geology's building here. We're moving really fast now. 1.5 billion years ago, Earth's very first supercontinent, Columbia, breaks apart. Then, a billion years ago, another massive, completely barren supercontinent called Rodinia forms. Now, Rodinia was so huge that it actually blocked warm ocean currents from reaching the poles. So, by 750 million years ago, as it started breaking apart, it triggered these massive global rains. And these rains essentially washed all the carbon dioxide right out of the atmosphere, plugging the planet into yet another brutal Snowball Earth era. But as that ice finally melted, life just went into absolute overdrive. Right around your left wrist, 530 million years ago, we hit the Cambrian Explosion. Suddenly, the glittering Cambrian Sea is just packed with marine animals. A huge spike in ocean calcium basically allowed organisms to start growing shells and skeletons for the first time. And this immediately kicked off a frantic, aggressive, evolutionary arms race. I mean, if a creature evolved a shell, the predator right next to it evolved teeth to crush it. To defend against those teeth, the next creature grew spiked armor. The pace of evolution here was just unbelievable. Yet, as we know, Earth is a pretty volatile host. Halfway down your left forearm, about 444 million years ago, the supercontinent Gondwana drifted slowly over the South Pole. And this triggered a massive, planet-wide deep freeze. Sea levels absolutely plummeted because all the water was locked up in glaciers. Now, for the shallow marine life that dominated the world at the time, no water literally meant no home. The resulting Ordovician extinction wiped out an astonishing 85% of all species on Earth. So for the 15% that survived, the water was still a terrifying place, full of giant, armored, jawed predators. So just inches away from your left wrist on our timeline, a creature named Tiktaalik does something completely unthinkable. It drags itself out of the water. To Tiktaalik, dry land wasn't some grand, brave adventure. It was a desperate refuge from the absolute monsters living in the sea. And amazingly, the land wasn't just bare rock anymore. When Tiktaalik dragged itself up, it was walking among Earth's very first true forests. Now we're at the base of your left hand. 252 million years ago, the Earth suffers a near-total reboot, famously known as the Great Dying. The Siberian Traps, which was this massive volcanic complex, erupted continuously for a million years. It pumped just unbelievable amounts of carbon dioxide into the air, completely turning the oceans acidic. The destruction was nearly total. 96% of marine species and 70% of land animals vanished forever. It is, without a doubt, the closest our planet has ever come to being completely sterilized. But life is resilient. Moving right up the base of the fingers, it recovers yet again. 175 million years ago, the famous supercontinent Pangaea cracks apart, basically unzipping to form the Atlantic Ocean. By 145 million years ago, the climate is steaming hot. We're talking zero polar ice caps, sea levels 200 meters higher than they are today. Earth is basically this lush tropical buffet, which allowed herbivores to grow to the size of 4-story buildings. Dinosaurs absolutely rule the planet for 160 million years. Right up until 66 million years ago, when a 10-kilometer-wide asteroid hits the Yucatan Peninsula, ending the era of reptiles in a sudden flash of nuclear winter. And that brings us to the era of mammals, because no land animal larger than 25 kilograms survived that asteroid impact. Period. But hiding down in the ashes were these small, crafty, shrew-like mammals. With all those massive dinosaur predators suddenly out of the picture, these tiny survivors literally had the whole world to themselves. They evolved incredibly fast, branching out in all directions to fill every single empty ecological niche. Before long, they became the bats, the grazing herbivores, and the fierce carnivores we recognize today. Now, right around 30 million years ago, while modern mammals and toothed whales were dominating the surface, beneath their feet, the Earth's violent geology was busy forging resources that humans would eventually rely on. Geologically speaking, the Earth was quite literally exploding. Across Nevada, supervolcanoes blasted billions of tons of ash into the sky. One of these, the massive Atlantic caldera, blew its top and collapsed entirely inward. And that collapse shattered the ground, creating this perfect network of vertical pathways that allowed boiling, gold-rich fluids to rise up from the magma and settle right near the surface. What is truly fascinating about an ancient geological event like that is how we actually search for its remnants today. Looking at these exploration techniques, historic miners essentially spent decades focusing on just one tiny spot on a map. They were totally limited by what they could physically see on the surface. But modern exploration teams like Nevada King, for example, they take a much wider approach. They're using drones, advanced geophysics, AI-driven data to actually map the geology mathematically. By zooming way out, they were able to map an entire 7-kilometer-wide volcano, revealing these massive underground structures that the historic miners just completely missed.
1 million ounces. That is the objective geological data gathered using these modern techniques, and it's pretty astounding. The data defines over 1 million ounces of high-grade oxide gold hidden away in this volcanic system. And because it's just been sitting there for millions of years, time has weathered the rock, making this specific type of oxide gold much cheaper and easier to process. It really is a perfect example of how combining deep geological history with modern technology unlocks resources that have been sitting right beneath our feet since long before humans even existed.
Which finally brings us to the very tip of your left fingernail. The timeline here moves at an absolute blinding speed. Millions of years ago, early hominids start walking upright. Just 800,000 years ago, our ancestors finally figure out how to control fire. A mere 40,000 years ago, Homo sapiens become the very last surviving human species on the planet. And right at the absolute microscopic razor-thin edge of that fingernail, just 5,500 years ago, human civilization as we record it actually begins. It's honestly an almost overwhelming perspective when you step back. Think about this quote. Nearly 4.5 billion years after Earth formed, an organism evolved that was able to read, write, and start asking big questions about how they got there. After billions of years of toxic slime, global ice ages, intense volcanic reboots, and catastrophic meteors, we showed up. We are quite literally the universe studying itself. Which really just leaves us with one final profound thought to chew on. You can look across your entire wingspan right now and see the massive, violent, completely unyielding journey it took just to get us to this exact moment. So, given the incredible, stubborn resilience of life over the last 4.5 billion years, what do you think is waiting for us in the very next millimeter?